microphone, a pointer, computer. I need one more hand. Does anybody else have an extra hand? So I work at the Stroud Water Research Center. I'm director there, and Stroud is about fresh water, pursuing new knowledge and stewardship of fresh water. And one of the reasons we had to do this building was because of just a long series of growth spurts by the center, growing from a local organization working on one little creek, White Clay Creek, to a regional organization, to a national organization, to a global organization. So right now, we are doing a lot of work in Pennsylvania, as you can see all these active study sites that we have going. But we are also doing a lot of work throughout the United States on some of the, what we think are the more significant rivers, like Susquehanna, Mississippi, Flint River. We're doing work out in California, just a lot of work in the United States. But we also have a global reach now, and so we're working on, right now, 6 of the 7 continents, including Antarctica. Doing work in New Zealand, Papua New Guinea, 2 of the largest rivers in the world, Amazon, Congo. And so we're busy. We have a lot more employees now than we did 45 years ago when we started. And when we started, this is what the Stroud Center looked like in 1991. Now this was after 25 years of existence. Basically, the Strouds agreed to build this building that ended right there. That was the original building. And over 25 years, we added a little bit more space and a meeting house, but it wasn't really that significant. But in 1991, things started to change. That was the second year that I took over as director, and we developed a new strategic plan. And basically, we were going to increase the depth and the breadth of our scientific expertise, and we were going to create an education program, and we were going to do public outreach. And so that was really new and exciting. And all of a sudden, school buses were arriving at the Stroud Water Research Center that hadn't been there for 25 years. Very quickly, within a couple of years, we outgrew that space that I just showed you, and we had to do a complete renovation of the Stroud Center. We had to have a new entranceway created because the whole facility had to be accessible to anybody that was physically challenged. We had to add teaching space to the meeting house. We had to add new laboratories because we had new scientists working there. And we added a stream house, the world's first stream house, which is a greenhouse with basically flowing streams in it, which would enable us to do the kind of research that needs to be done and that really couldn't be done anywhere else in the world. And so we do that now. We have this facility. Very quickly, within 10 years, that new space that we created in 1998 became obsolete. Basically, as Susan said, very quickly, the teaching lab that we thought was state-of-the-art in 1998, we realized was overcrowded. We couldn't handle full busloads of kids. And by the way, school districts like to handle full busloads of kids. They don't like to send a partial busload because they have to pay the same amount for the driver, right? So it was crowded. We had no outside windows in the teaching lab. It was like it was a basement. It was a damp basement, and we needed to. It wasn't really facilitating what we wanted to have happen in that teaching lab. As Susan mentioned, we also had a gradual increase in our population of graduate students and postdocs and visiting scientists. And basically, by the year 2008, in each one of these dormers in our meeting house was the office of a graduate student. I mean, basically, there it is, 2.5 feet wide by 4 feet. And that is not creative to intellectual development. As she mentioned, I had my director of communication and marketing at the top of the stairway in our meeting house, the fire stairway. And needless to say, that person stayed for about 13 months and then left. I don't know why, but it's the only stairway in Chester County had a copy machine in it. And I had to move my development office, my public outreach office, over into the log cabin, which is completely disconnected from the rest of us. And so basically, Bernard Sweeney got together with the board and said, we need to do something here, and we need to create some more space. And we decided to build new quality space for main focus being for teaching, environmental programs, for offices for those teachers, for graduate students, postdocs, and so on and so forth. But also we decided to move all the non-scientific staff from the core Stroud Water Research Building over to this new building so that we could free up the existing building to be totally dedicated to science. So that was a strategic move. But we also wanted the new building to be able to house more chemistry and biology in the future if we needed it. So we wanted those kinds of things. The board gave me some broad sort of mandates to start the project. One was that we wanted the building to be green architecture. Okay, so this is creating a search image for the team that I was going to put together to build this building. It had to be green architecture. I mean, after all, if we were going to create a building to house cutting-edge science and research and education, we wanted the building itself to be cutting edge, to be at the forefront of the way buildings ought to be built at this point in time in human history. So we wanted LEED certification at some level. We wanted it to be a safe environment for the employees. We wanted the building itself to be a teaching tool. We wanted people walking in that building and going, wow, I've just walked through this building and I know more now about something regarding the environment than I did when I entered the front door. And of course, as Susan mentioned, we wanted to get the water right. We wanted to get every aspect of water in this new building and on our campus right, from stormwater runoff to how we were treating our septic to how we were dealing with roof water that landed, for rainwater that landed on our roof. And so those were kind of the broad parameters that I was given to put together a team, and that's how I wound up with Sandy Wiggins of Consilience as my project manager, Muscoe Martin of M2 Architecture as my architect, and his team, and basically Tom Nason and Nason Construction for building the project. So I'm going to turn it over now to Muscoe Martin, who was the architect of choice on this project. Muscoe.
Thanks, Bern. One of the really terrific things about being an architect in my situation, I do a lot of work for nonprofit organizations, many of whom are environmental groups, is the opportunity to work with some extraordinary clients. And if you didn't know how extraordinary Stroud was until you heard Bern speak this morning, it's really amazing. These guys are doing some amazing work, and are the lights going on or off? Am I imagining that? Am I doing that? No. I'm not. You don't need to see me, so you can see the pictures. Working with Stroud has been really inspiring to me and challenging, because they challenged us to work at a cutting edge, to match the work that they're doing around the world with what we could do for them in this building. One of the other great things that I really love in my job is the ability to work with some amazing team members. And in fact, Michele Adams from Meliora introduced me to Stroud and to Bern. So in many ways, she came first in the team. And Michele and Jose and I have worked together for a long time. We'll just leave it at that. We've done a number of projects together, and that team work is critical to our successes, I think. So the thing that we're learning about designing buildings and sites that have a high performance requirement, whether it's getting the water right, getting the energy right, getting the materials right, getting the indoor health of the occupants right, is a collaborative effort. We have to work together. I'm an architect. I know a lot about buildings, but I don't know a whole lot about water. I know much more than I used to, but I don't know a whole lot about landscape. I don't know a whole lot about heating and cooling. I know just enough to get into trouble on those things. So you have to have a team, and you have to respect that team to give you information, to give you input, and to work together. So one of the first things we did when we were hired, Susan mentioned that we first asked the client to develop some touchstones or guiding principles, which they did, and we helped them through that. We then engaged in a charrette, and many of you probably have heard the term charrette. In this case, we use it as a design workshop, and we did a 5-day event at Stroud, bringing in our entire design team, staff, and board members from the organization, neighbors, regulatory folks, an artist or two were there, potential funders, in order to gather input about where the building should go, how it should work, what the key factors were, how to take those touchstones and turn it into a design. And part of that is education. Here you see Michele on the first morning of the charrette explaining to 50 or 60 people how hydrology works, how the hydrology works on that site, and what kinds of things we need to do to improve the health of that site. This was the existing site before we began. Let's see, is there a pointer here?
Button right there.
Okay, thanks. So Bern showed you the existing building. That's the stream house, which is the greenhouse. There's some other ancillary structures around. There wasn't a lot of place to put a new structure, but we had identified 5 locations, and the main purpose of the charrette was to figure out which one of those it should be. So we got everybody out on the site immediately, walking around, looking at the site, getting a sense of how it worked. A lot of up and down, a lot of topography. And then we began working in small groups. You probably all have been part of these kinds of things, splitting up into small groups. There's somebody from the design team, a board member, committee member, neighbor, artist in each group, all beginning to put these pieces together and figure out where the best place to put this building might be. And after meeting in small groups, then we present where everybody is. And over the course of that first day, we developed 5 or 6 schemes for where the building can go, how it might be configured. At this level of detail, looks pretty crude, and in essence it is, but encapsulated in these little sketchy sketches, as we call them, is quite a lot of information about what is most important to each of those groups. Put them all up on the wall, begin to look at it, talk about it, and after that first day, we discovered half a dozen really important things that we didn't necessarily know before. The first one was Stroud really loved their stream house. That's why the heart is around the stream house. So, yeah. Because some of the group said, well, let's tear it down or let's move it, or do we really need it? It's kind of in the way. That was not going to happen. It needed to stay there, and it was very important. It really, in some ways, was becoming the heart of the scheme. Some of the other things you can see here, creating an easy flow of people, wanting to make sure that they could connect from all parts of the building into the new structure. No more natural flow of water, making sure we have good daylighting, natural lighting in all the work and study spaces. So that was the site there right next to the stream house. It's sort of sad now seeing what the lovely meadows look like before we put the building there, but hopefully we've improved the overall site. Even though we lost a meadow, we gained something else. So we were going to connect to the stream house. So here were the 2 schemes that kind of bubbled up to the top, and there really were 2. And in Stroud's way, they named them. One was called Stonefly, and one was called Caddisfly. And apparently there's some actual inherent characteristics of those creatures that maps to these building designs, but I'm not sure how that works. So there were 2. Yeah. And Caddisfly was the one that in the end bubbled to the top. And you can see that there's the stream house, so it's connected like this. And one of the key things we need to do is reorient the site and make a new front door. So that's the front door when we began work, all the way down here, but the parking is here. So we needed to kind of create a new front and center door that gave some architectural interest to the overall composition. So remarkably, from the day 3 of a charrette involving about 50 people working together over the course of those 3 days, the final design is almost exactly what you see there. You developed it a little bit more, and one of the key things that we began to work on once the building location was developed was how to incorporate and integrate the site work. And that meant circulation both for people, for vehicles, for water, for critters. So how we get in and out of this building, how we kind of travel up and down the slope, how water is going to flow on this site, rainwater, and the stream water, how people are going to move throughout the building. That became a very important aspect here. So as you see, the drawings start to get a little more detailed, a little more finished, a little more professional looking, but the key decisions that got made on that day 3 with all that input really carried through until the built project, which I will say doesn't always happen. We aren't always able to take it all the way through, but in this case we did. So a couple of things that came out of the charrette that were really important, that connection between the existing structure and the new building. And one of the conceptual blockbuster problems that we had to get over was how do we get through the stream house, which is a place of research, but how do we use that as a circulation node, if you will. And what we discovered that we could do was actually build a second-level bridge that would pass through the stream house, allowing people to look down and see what's going on, but they couldn't stick their fingers in the experiment and mess with it. So being able to build that, conceptualize that bridge, and this was a sketch that came out of the charrette that showed, well, we could have a bridge that went there. And Bern said, well, wait a minute, we can't have a bridge in the greenhouse because it's going to block our sun for our experiments. So I had a young associate in my office said, well, I've seen a glass bridge. You can actually build a bridge out of glass. Sure enough, that's what we ended up doing. The importance of that front door here, sort of having a kind of front porch, front yard, if you will, was part of this. And a backyard that looked out towards the creek and towards this very lovely site that Stroud sits on. And being able to see through, one of the things that they didn't have in their old facility, in the way it was currently configured, was the sense that you were actually on this really beautiful place and that there was a stream out there that was key to their research. So making sure that was part of that, the view of that. And then some ways to get in and out of the building, both for students and for service. Now, I mentioned that the important thing about the teamwork is kind of getting to this high level of performance. And in terms of getting the water right, one of the things that meant for us was that all of us had to work together. Civil engineer, the hydrology, the landscape architecture, and the architect all had to get this right. And one of the key things about getting the water right here was where the building goes, and not just in the X, Y directions, but in the Z direction. So where the front door, the elevation of the front entrance to this building became we spent weeks getting that right. And because you got to get the people in, you got to get the water around the building. So sort of adjusting that situation is a critical aspect of getting the water right here. There's our little sketch from the shred of being able to cut through the stream house and see the experiments that are going on down below, but again, not be able to mess with them. And this was, again, from the charrette, a kind of sketch of what the front door might look like. And it's a little bit crude, but the key thing there was that we wanted a front door that was inviting, and that on the second level was the library. And there was this idea that the library should symbolize knowledge, research, et cetera, and it really should be a kind of guiding light that draws you towards the front entrance of the building. So this rendering came much later, after a year's worth of work, really developing the details. And this is from the back side of the building. You can see the existing structure over here, the stream house hiding there. And the design of the building sits in comfortably, we think, within the context, the vernacular context of a fairly rural agricultural site, meant to look a little bit like a barn, similar materials to what they had on the existing structure, but taking advantage of the fact that green architecture was a key thing, using local materials, locally quarried stone, and you'll see that as we move into to some of the construction photographs. Now I'm passing it over to Jose, I believe. You can see better. Uh-oh, did I do something?
No, it's okay. Here, right? Well, there is a fundamental question that we face in every project we tackle. And the number one question is, what is the water coming from and what is the water going to? And you want to track that flow of water because, as Muscoe and I talked about it, form follows flow, but form affects flow. So you have to be very conscientious about those decisions that you're going to be making, because you're going to be making some significant transformations to the existing conditions of any place. And we feel that it is our responsibility to actually provide solutions that actually are positive contributions to the circumstances of any one site. So we started a very large scale, really understanding where the site is located. This is just a copy from a USGS quad map. You see White Clay Creek here. What is it telling us? It's telling us that the site is facing west. So afternoon sun is important. Morning sun is going to be scarce. So think about how do you place walkways and orient buildings and so forth and so on. There's a certain amount of water coming through this slope, as you can imagine, draining down into this valley. So water was important. So as we need to navigate through these slopes and decide, we do an analysis of what is steep, what is flat, what are the places where we can carefully circulate, and the places that we're going to have to spend a little bit more energy, moving up and down. And then, of course, we looked at the way that topography has actually moved water through the site, and in doing that has generated different types of soils, and really understand how the water is going to actually move through the soils and make it all the way down to the creek. And how are we going to begin to affect that? What the general geology of the place is may inform us of circumstances in terms of understanding the capacity of the site to infiltrate runoff or not. One of the things that we were trying to do was to get the water right. So to get the water right, you want to mimic, pre-existing conditions, hopefully ones that are equal to the forested landscape that occurred there centuries ago. Then what kind of existing systems are in place? Woodlands along the streams, cultivated landscapes, man-made interventions, but really understand the basic bones and structure of the site, because these are your building blocks. How do you move around? As I mentioned before, aspect is a very important circumstance, because aspects transforms into essentially BTUs per square foot of solar radiation. And as you think about that, that is going to be affecting temperatures, the way you feel on the site, the way you navigate through the site, whether it is morning or afternoon, the way you connect to the circadian rhythm at 12 o'clock noon every day. But also, how do you organize, the new landscape and the new living systems that are going to be on the site? This is actually the way energy is moving, and gives you a good understanding of that. And then really understand how that all those factors, as you try to understand them, you simplify them in a way that tells you, what is, for example, a series of plateaus or transitional slopes, and how are you going to be moving around. We believe that with positioning the landscape comes responsibility. And for everything that you do on a site, you have to be aware of what are the consequences. So understanding how the water moves through the site. And if you think about it, the original construction of the original buildings, they're placed, taking advantage of the views and the proximity to the creek. But in a way, they are acting like dams for the water to go from uplands down to the creek. So it became a fairly significant challenge for the project to really understand how the building had to be constructed and all the interventions on the site to let that water that originates in the uplands find its way all the way down to the creek, both at the surface level and below through the site. Another aspect of it, as Muscoe was describing, is how do we circulate through the site, and how do we accommodate the number of parking spaces that are required? How do we think about overflow situations so we don't design for Black Friday when we have the internet available to us, and Black Friday is no longer Black Friday. We want to make sure how little can we build, not how big can we build, and how do we take advantage of the existing conditions that we have there? Can we actually turn a bus around? Can we actually utilize areas of the site that are underutilized? And then how do we get from parking areas and arrival points to the destination, the entrance of the building, circulate through the building? How do you manage the flows of people, whether if somebody that comes to visit versus a group of students in groups of 50 or so? And all of them have to be compliant with current regulations and ADA accessibility. So there were a number of entry points that we needed to connect, and a number of arrival. But we think about the journeys from those, arrival points or parking areas to the destination and the building as teaching moments. And how do we inform those journeys, I think, is part of the brief and informs the design solution. So I'm going to turn this over to Michele to tell us a little bit on a broader scale where we are on the site.
Thanks, Jose. And as Bern and Susan and Muscoe and Jose have mentioned, getting the water right drove everything on this project. And so it's our watershed address, not just in the White Clay Creek, but thinking about how everything we do affects ultimately the Christina River and the Delaware Bay. And so in the charrette process, we looked back to when the site was Penn's Woods, and we still have about 45 inches of rainfall, but that wonderful woodland landscape and soils were this beautiful sponge that took all the water such that there was very little runoff. And the trees and the forest put the water back up in the atmosphere. So that was sort of our guiding touchstone of could we build a site that did that, because as we've changed our sites, we still have the rainfall, but as everyone here knows, we have tremendous amounts of runoff from our built landscapes. And this is the most boring numbers, so bear with me a minute. Early in the project, we looked and we said, well, how much effect can this site out in the countryside really have? We saw that it had a good amount of impervious and a good amount of lawn. And when we started to put some numbers to that in the charrette process, we found that in a forest there'd be about 1.8 million gallons a year of runoff. But with the site as it was, we were generating about 3 million gallons a year of runoff from this pretty rural, nice-looking naturalized site. And so that became a touchstone. How could we put the site back to work more like nature? And so could we make that work? And other things to think about was Stroud had an on-site well for its groundwater and an on-site septic system, but it was a traditional septic system generating nitrate and the various pollutants. And we weren't thinking about how those systems were really connected. So we looked at the existing site, and when we looked at how it worked, there was a mushroom house at the top, and that was generating a lot of runoff coming out and down the road to driveway down to Spencer Road. And on the site, things were sort of just going and hitting the building, but there was no stormwater management per se, and ultimately everything was getting to the creek. And so we started to look about taking the site apart in pieces. And this was part of the charrette process. And we started at the top of the hill and followed the water down, drop by drop. And up at the mushroom house, we said, what if we could take the water and have a series of rain gardens and infiltration trench and take the water in another direction and off to a level spreader that dispersed it gently into the meadows and buffers. And down below, could we do the same thing? Could we put a system in? We had to bring water between our new building and our old building, but could we have a series of rain gardens, level spreaders, a green roof that put the water back in the landscape along the way instead of piping it all someplace and let it soak into the ground? And so getting the water right was the theme. And the other components of that were a constructed wetland system and a rainwater cistern, both above and below ground, but a constructed wetland system that would take the wastewater, treat it before it was discharged to a drip field, and have a cleaner level of pollutants. And maybe someone else wants to speak to that a little more. So there's the site after the building had come into place. And there were a number of things along the way, and maybe at this point we ought to all kind of pass the microphone around, because getting there wasn't easy. We had a geothermal system that had to go in first. A geothermal system is anything but easy to construct. It makes a lot of muddy water. And so you can see the challenges of a site like Stroud not having muddy discharge to the creek. What we ended up doing was constructing a sediment bay for all the material that was coming out of the geothermal wells in the back in some of the what would become rain garden and wetland wastewater systems. Is that right? Did I get that one right?
So we, a couple of things that are of notice here about the complications when you're trying to do this. We initially felt that it was very important to make the constructed wetlands ensemble a very important feature of the site and the project itself, and we wanted to place them in the new courtyard formed by the building. The problem with the systems is that they need to be level. They need to be absolutely flat terraces. And we had a site that is sloped, as you noted before. So we needed to actually create a series of level plane of areas and then thread the circulation so we can achieve ADA accessibility for the entrance to the student area here. In doing that, we knew we were going to create a series of changes in grade, and then hence the opportunity to create a series of gathering spaces and moments. So this is intended to be an area where the students can actually gather before they go into the classroom, or they gather after they come out of the classroom. But in the process of doing that, they go through the constructed wetlands through the filter and the wetlands on either side that flow by gravity from uplands here all the way down to, and then up to the site. The rain gardens, on the other hand, were designed slightly different from the various conditions. The rain gardens that were actually located downstream from or downhill from the building were not lined, so they can actually maximize the infiltration capacity of the soils and take advantage of that. The rain gardens that were built uphill from the building were actually lined, which is very interesting because, you know, in the future, if we want to do any kind of research and understand how the soil and plant system and the microbial activity of the soils interact with water quality, we have opportunities to manage and study that later on. So this is the project completed. In the process of doing that, all these paving systems were actually designed in a way that responsibly move water to the places where we wanted to have it. Next. And then taking advantage of some of the extraordinary skills that we had for the people that constructed this. And I need to give a shout to Peter Johnson that is with us here in the audience that took it upon himself to, you know, carefully laid out every single stone of the site and cut it in a way that actually expresses the way that water moves through the site and becomes features actually of the project itself. Next. So you can see the constructed wetlands in the back. The retaining walls necessary to accommodate the changing grade became sitting areas for benches. A fully pervious paving system that reduces the amount of runoff being generated. These are some photographs of the construction and the site after the first summer of growth. This was finished, I believe, in September this past year.
I'm just going to jump in here. One of the things that was we really tried hard to do here, working with Michele and Jose and the Think Green team as well, was to really integrate the building and the landscape. So the idea was not to have this green building that's sort of plopped down on a flat plane and then we just plant stuff around it, but really to make them work together. And I mentioned that settling the vertical elevation of the building was really a critical part of this. But it's also things like having this rain chain and little rooflet here that actually quite a lot of rain is making its way down to this little roof, and a rain chain that comes in here and connects to that rain garden. Using materials, the stone materials at the building, on the base of the building, as well as in the site. And frankly, when they told me that they wanted to have the sewage treatment plant as being right out in the front court or the back courtyard here, I was a little concerned. But this is in fact our sewage treatment plant, right? So it's pretty nice as those go.
Oh, thanks, Muscoe. And one thing that they did very well at Stroud was there's many types of best management practices, from the rain gardens and the daylit water that splash blocks and comes into the rain gardens, and a green roof. But instead of being the usual Chinese menu, because people tend to think of stormwater and all these practices as a Chinese menu, and you'll have 2 egg rolls and some whatever. Instead, it's a working system, and the different components connect. So the green roof and the roof areas that overflow through the system, through the cistern, through the rain gardens, everything is connected as part of a system. There's signage for education, so the visitors can find their way and understand what's happening both above and below ground. And then as we get to the end of the pipe, we have level spreaders, which are really perforated pipes hidden in those. This is actually an engineered system here. There's a perforated pipe, but covered in stone, meant to look like an old stone wall that lets the water disperse along the level contour rather than, an outfall with riprap and erosion. Porous pavers, as Jose mentioned, and there's cisterns, and there's both an above-ground cistern and below-ground cisterns. And maybe, Bern, do you want to talk about drinking your water isn't easy?
Yeah, so we incorporated cisterns into the project because we wanted to capture the roof water. And we wanted to use it initially to flush some of the conventional toilets in our facility and for washing your hands in the laboratories and for a source of high quality research grade water, which is much easier to produce research grade water from rainwater than it is from the well water. We wanted to move away from the wells. But ultimately what we'd like to do is drink the roof water. But right now, the Stroud Center, because we have so many employees, we have over 50 employees, we are a commercial water provider. And at the present time, a homeowner can drink roof water, but a commercial water provider cannot take roof water and provide it to the public, right? So I can't take the roof water from this facility and provide it to my employees because it's against the law. There's no infrastructure in place to do that. We've petitioned the EPA to get a memorandum of understanding that if we do the research, we've built this building so that we can do the research to prove that a commercial water provider can take roof water and make it potable. And we are going to do that. We're about to get a memorandum of understanding from the EPA to try to do that. But we have so I think it's going to be, we need to do that, right? And we need to do that in this country. It's being done everywhere else. Why not in the United States? And so we have this several thousand gallon tank in the ground and this really beautiful teaching cistern to the right. Really, ultimately, my goal is to be able to drink the roof water, and we will do that. You will come to Stroud Center someday and drink the roof water. I don't know how soon that's going to happen, but we will do it.
You get the bird droppings out of it?
That's part of the research.
No, that is a really, that someone asked about the bird droppings, and you know, it seems like you ought to be able to drink your roof water, but bird droppings are one of the many things that you need to worry about. The other thing is that in urban areas, you may not want to drink your roof rainwater directly because the rain falls through the atmosphere. The atmosphere in urban areas is full of particulates, smog, et cetera, and essentially our rainwater is not really safe to drink straight. We are treating the water at Stroud. It's got multiple levels of filter. There's a so-called first flush diverter, which takes the first few hundred gallons. So in theory, the bird droppings and those kinds of things get flushed out initially, particularly if it hasn't rained in a while. And then we have a series of other filters and also ultraviolet disinfectant. So that does require some processing. But the possibility then of actually taking it to the next step and being able to turn that into potable is what should be pretty exciting.
Yeah, one of the sort of hidden agendas of this project, if you wish, is the idea that we see a significant opportunity here to change the way the regulations are applied and the health codes are applied to the use of water. And the idea that we can think about decentralized water treatment systems that are actually function with solar aquatics, that take advantage of life forms, that actually can produce very high levels of pure water, which in many parts of the world are actually in place, but we can't do it here. We find that this is a significant opportunity, and if we hit all the notes, I think we'll be able to make a change on the regulations, and we couldn't think a better group to do it at the Stroud Research Center.
So these are some photographs of the actual built structure. This is the front entrance way now with the library, and you'll see in a little bit there's a kind of nighttime evening shot where the library lights up. But so this is kind of just right there from that original sketch that we did at the in the charrette. A few things that we tried to do, again, kind of trying to make visible the flow of water through out the site, is the little curve, and it looks like maybe they didn't build the roof quite right there. That's actually done on purpose. So the roof actually drops off, and that's a low spot, and you can see the rain chain coming down here, and it's starting to pick up some beautifully arranged and crafted stone work there. I'm going to make Tommy embarrassed by thanking Think Green again, and Peter. But so that you begin to see that right at the front entry how rain moves around this building. So it's really kind of right in your face, hopefully in a good way. And this is in the foreground here is one of the rain gardens. So having that be part of the view of the building as you're moving through the site. looking down from below that one rain garden back up at that front porch.
And this is a lined rain. This is one of the there's 2 lined rain gardens right in front of the building, and this is one of them.
Right. Because we didn't want that water infiltrating in and then soaking into our basement. Not such a good plan there. But you see, looking back up at the rest of the site and the substantial topography that we had to wrestle with. From the back side of the, this is the constructed wetlands are hiding back in there. This is part of the filtration system for the constructed wetlands, which we've wrapped in a jacket of perforated metal, which has the possibility of having eventual signage attached to it. You can't quite see the solar panels, which are actually located right up there.
The green roof.
Oh, and a little bit of the green roof. It was a very small little green roof. Michele showed you a detail of that. That's off of. It's actually off of Susan Gill's office. She has quite the nice office, looking right at the green roof there. Couple of notes about non-water stuff here. Bern mentioned at the top that energy efficiency was really important as well, and trying to make a building that uses little purchased energy as possible. Bern told me early on that he can raise money from funders to build a building, but he has a hard time raising money to pay his electric bill. That's not a sexy thing to contribute to. So if we can do something in the design of the building that will lower those overhead costs over the next 50 years of the life of the building, that goes a long way towards making it a more sustainable organization, both economically as well as environmentally. So we spent a lot of time making sure that would work. We're using ground source heat pumps. There was an existing well field, and we added to that. All the offices are naturally lit, and you can see the windows have little sunshades on them that keep the direct sun from coming in, start hitting your computer, but allow natural light to bounce around so that the daylighting is very efficient, effective. There you can see the solar panels, some of them anyway. And looking back up at the building, green roof here, the constructed wetlands in the lovely way that you sort of make your way up through the site, and kind of you sort of follow the path of water, if you will, as the site moves around.
I must interrupt Muscoe here for a second, and because I think he's too modest about what he has done here. It is an extraordinary building. It is a building that, as you can see, has a relatively narrow footprint. Every single room of this building has daylight. Every single room in this building has the possibility to look at the landscape. It's a biophilic building by definition. And I think that it just will make the people that occupy the building and take advantage of this facility much happier and healthier, for that matter. And I think that that's really something that is very important. It was a driver as part of the design. Just as important as making the water right was to make sure the people were feeling right in the building.
Thank you. I'll give you your money after the... One of the other things that affected the shape of this building, and you can see it's got some kind of little funny jogs and zigzags, and some of it is just to kind of break up the overall mass of the building so it didn't seem quite large, because it is actually a pretty good sized building. It's about 15,000 square feet, so it added a significant amount to the overall size of the complex. But also there was a setback, both the regulatory setback, or mandatory one, and then a kind of a recommended setback from the creek. And Bern and Stroud were very adamant that they wanted to stay out of those buffer zones, because that's what they preach as part of their work. So you do see some funny little jogs, which in hindsight, maybe look odd, but if you understand how they sort of, we managed to miss those buffer zones. That was part of it as well. So here you can kind of see the money shot at night, and I'm particularly pleased with the way we ended up with having that kind of library as a symbol of the sort of education and research that goes on at Stroud as the kind of the window that draws you to the front entrance, and the front door really is directly underneath that. So you move in here with that sense. Now you don't necessarily know it's the library as you're arriving if you're a visitor. but we all know, and that kind of made for a really great way to do the front door. Is that it? Did it work?
So you originally had, did some analysis to show how much water came off the site above and beyond what was a natural forest, and then you added considerable amount of impervious surface. Are you tracking to see that you met your design objectives to get back to where you originally wanted to?
Thank you, Owen, for that question. Oops. We have a couple, if we could hold the lights for 1 minute, because I'll let Bern to speak to these last couple photos, and then we have a video.
So yeah, to answer your question, we did. I mean, basically, this is what the runoff looked like from the site pre-construction. So we had every rainstorm we had muddy water coming down our entrance driveway. Next slide. And this was that same view during Hurricane Sandy. So yeah, we got the water right. We got the surface water right. We got the groundwater right. We are now, so this is our entrance driveway pre-post. This is Hurricane Sandy. And so, next slide. So what I wanted to make a couple of final comments. Could we get the time-lapsed thing, the 1 minute long time-lapse thing ready to go? What I wanted to say was a couple things. One, we did get the water right. The wetland wastewater treatment system, which was provided to us by the Pennsylvania Department of Environmental Protection as a demonstration site, is working really well. Basically, the inflow to that system is around 25 to 30 parts per million nitrate, and the outflow that we put in the ground is actually less than 5 parts per million, a lot less than 5. So we're actually upgrading the groundwater with the effluent from our wastewater treatment system from this building.
Hi. One of the reasons it's always tough to get people to agree to install BMPs like you've used is they don't feel like they understand the maintenance, they're afraid of the maintenance and the cost. So Dr. Sweeney, could you talk a little bit about what your experience has been in maintaining this? Who does it? Is it your staff? Are you hiring? And what kind of costs you're seeing? Thanks.
Yeah, so I guess the question was about the maintenance and the cost of those and what we're seeing, and so far the maintenance costs of this building are really low. The energy, we did a great job on the energy, so the energy consumption is really low. We're generating somewhere between 18 and 20% of the energy needed for the building, on the building itself. It's totally insulated. It's really tight. We use soy-based insulation right on the inside. We have some really interesting insulation for the ceiling and floors that actually not only created good insulation qualities, but are a total fire barrier for the inside of the building. So we didn't even have to put a what do they call it? A sprinkler system in, because that insulation came from as a byproduct of the steel making industry. So it's recycled steel materials. The cost of this building is a lot less than our original building. It makes our other building look, what can we do for that? But it's hard to retrofit an old building. Overhead is really the killer of not-for-profit organizations, right? So nobody wants to support it, foundations don't want to support it, and so on and so forth. And so it was really important in this building that we do it the way we did it. I actually had a person come to me at the beginning of this project and say that they would pay for the entire building. They'd give me a check for the entire building at that moment if I would put up a regular building, like a warehouse kind of building that didn't have all the super energy stuff on it. And I said, you know what? I can't do it. I couldn't walk to work every day and pass that building know that I could have built, knowing what I could have built. And so I said, I'll raise the money on my own, and I'm still doing that. And so I'm paying a steep price for that. But I think that in the long term, not only is the Stroud Center better off for it, but Chester County, I think the world's better off for it. So I think we made the right investment.
Christine, I'm sorry. What I really meant was the landscape, the stormwater BMPs. The maintenance of those.
Oh, God, I'm sorry. I blew that. Yeah, so I don't know if I can, you want to know about the cost of those things and the maintenance of them? Well, the maintenance of, we think the maintenance is going to be pretty minimal. I mean, we were spending a lot of money mowing lawn, right? So now, instead of mowing lawn twice a week or once a week, we periodically need to go into those rain gardens, but they're planted pretty dense with the right kind of plants. Now, are we gonna have to do a little weeding? Yeah, we are. But for example, the pervious pavers are constructed in such a way that our old paving system, we had to go in and either herbicide or weed whack periodically because we had weed problems. These are made so that the rainwater actually goes through and it becomes more or less not very moist underneath the bricks so that weeds aren't going to germinate. They're not going to be able to survive in that environment because there's no moisture. So basically we think we're going to have a lot of lower maintenance costs for like the walkways that we created. And I think the rain garden is going to be a lot less energy and time sink because of the way they're constructed and the way they were planted. We planted them right. So yeah, I think we actually reduced our overall maintenance for the outside landscaping in this project. I'm sorry, I missed that in the beginning. Yeah.
Just to add to that, because I think that this is probably one of the things that you want to hear about it, is that you saw the numbers that Michele put up before and the amount of acreage, I think 1.75 acres of lawn. Everything that was built for this project was either a rain garden, a pervious paving system, low grow or no mow lawn, and a meadow. So all of those things have a couple of features attached to it. One is that, you know, the amount of energy to maintain them on this stage, avoid succession, keeping all the woody plant material out of them, is highly reduced. Meadows are mowed maybe twice a year. And low-grow lawn has to be kept to a minimum height of about 4 to 6 inches. You can still walk on it, you can still put your toes on it, but you don't have to fertilize it and you don't have to actually mow it as often. So.
And, yeah, I was just about to say, Peter, go for it.
Just so you understand, the,
Peter is from Think Green, and while Peter's coming up, I just want to say that maintenance is important, but construction is everything. And when you're building rain gardens, it's grading with a spoon, not a shovel, to get the grades right. And so that, and the soils and the materials. So go.
I think you guys do want to hear about the plants and the water and all those things that go on. Well, I was lucky enough to be the contractor selected to do all the landscape construction, included the rain gardens all through the stonework. One thing I should mention is probably within 10 miles, all of the stone came for the boulder work in the rain gardens. Within 10 miles, North Creek Nurseries supplied all the plugs, probably 95%. So all native plants, you know.
Real native.
Yeah, I mean, it was exactly. So the one thing I wanted to mention real quickly, though, is the pictures you saw of it finished, that's less than 1 year of growth. So the soils, the grading, the drainage, how it all worked, the erosion and sediment control, which was complex, but we got it. By the end, that finished product was less than a year of growth. It was finished, the planting was completed June 15th. There was some meadow work that had to go on throughout the year, but by the time the photos were taken, I think it was October. So it can be done. You do need to plant densely. The maintenance on the rain gardens, I just did a recent proposal to be doing some more maintenance there. But we figure it's going to take 2 to 3 men, one day. What we're shooting for is to weed the rain gardens. So there'll be minimum weeds, okay? Mowing goes from once every 1 to 2 weeks to once to twice a year. So, you know, it's a big impact. And so thank you to all you guys, my mentors, and lucky enough to build a great project for Bern and be a part of the team.
Thank you. Joe?
And Bern, this is for you. I think you probably have monitoring up and down the creek and have done quite a bit of that for many years, probably still doing it. have you had enough time to look at some of that data and see what the impact has been of this construction and post-construction area?
Well, as you might suspect, we were very cognizant of the best management practices that were put in place for construction, and make sure they were put in place and maintained during the construction period. So we had maybe one or two very small instances of breach of those things, but basically they held for the entire project. So we had no breakthroughs in the precautions that were taking place to keep surface runoff or sediment from leaving the facility. We actually have 24/7 monitoring of sediment and a lot of chemistry in the creek downstream and upstream from this project, and we weren't seeing much at all. And in fact, now, as you saw, we're infiltrating everything now, and so our impact on our campus on the creek has been greatly reduced. It was small before because we were doing some really good things, but now it's really, as Michele said at the outset, we wanted our campus to be like it was 500 years ago when it was an old-growth forest, and we're getting close to that. And I think we want to demonstrate that you can do this if you really want to.